So now let's look at the next question. Is about this helicopter taking off vertically. This question actually combines a bit of kinematics and forces. So at the very beginning, they tell you that time is 0 and it is at rest. So it means that your velocity is basically 0 at time equals to 0. Then it says that it has an upward acceleration as a constant. So now I know that my A is a constant number, is equals to 0.40 meter per second square. So this is my habit of answering question. I will just sift out all the information in a form like this, so that I will know which information I have used. Sometimes if I cannot solve the equation, I will look through, which information have I not used. Okay, so I will just write it back down here. You are given the mass. Okay, so I know my mass is 14000 kg. This acceleration of g of free fall is basically telling you that your g is actually 10. Okay, please do not confuse this acceleration of free fall with this acceleration. They are different. Okay, this acceleration is basically telling you what is g, in case you need to find the weight. Yeah, okay. So let's analyze it. Okay, I have to find the speed at t equals to 20. So I know that it starts with 0. I know that every second I know that acceleration is 0.4, meaning that every second that has passed, my speed will actually increase by 0.40. And now the question is telling me that 20 seconds has passed. So very easily I can basically do an equation, a equals to v minus u over t. Then after that you can find out. So your a is 0.40, your v is the unknown because you want to find the final speed. Your u is started off as 0, so that's your initial speed. 20 seconds has passed, so your v is just 20 times 0.4, and I think the answer is 8. If you do not like equations like that, you can also write like a equals to, present it properly, a equals to 0.4 meter per second square. You know that every 1 second your v will go up by 0.40 meter per second. So because of that, after 20 seconds, basically your v is 0.4 times 20, which is also 8. So both ratio method and the formula method will work. Okay, but in our case, I suggest you use the formula method, which is quite straightforward. Okay, after that, you are supposed to find the resultant force as it rises. So down here, right, this is the helicopter. I will draw a free body diagram. Since it is on Earth, definitely there will be the weight. Yeah, it is rising, so it could be having some drag force. It is moving up, right? So it is moving up. So if it is moving up, that means your drag force or your air resistance will oppose its movement. So actually your air resistance and the weight will be in the same direction. Now you can find out the weight because you know the do you know the mass? You know the mass, and then you know the mass over here, and you know the g. You can find the weight, but do you know how much is the air resistance? You do not know. So to find this resultant force is also known as net force, F net. Yeah, so you find that if I just take W plus air resistance, I do not know my air resistance, so I cannot find. But what you know is that, well, your F net, remember these two equation, this one, this is first equation, second equation. So if you use the second equation, you find that W plus air resistance, but I don't know the air resistance, so you are stuck. So what you do, switch to the first equation. So use the first equation, F net equals to MA. Well, do I know my M? Yeah, I know my M. It will be 14,000 kg multiplied by an acceleration of 0.4 here. Right? So by doing that, I can actually find my answer. So this answer, F net equals to this. This is the direct answer for your part B. Okay? So this one is your answer for part B directly. Okay, lastly, I need to find this upward force. And I think I make a mistake. For the helicopter to rise, you will definitely need an upward force, right? So I think there's an upward force. Okay, so I think apparently there's no drag force, there's only upward force. Okay, if there's drag force, then you cannot solve this question, because then you will have two unknown with one equation. So now to find this upward force, this upward force which is here, yeah, then now you can use your equation number 2. Your F net is equals to sum of forces. So this sum of forces, you will have F plus negative W, right? Because you are moving up. So let's take up as the positive. And then in part B, you have already found your MA. Yeah. So now what you can do is that you can sub values in. Your M is your 14,000 kg. Your A is 0.4. Yeah. Then after that, you will have your upward force. I call it F, simply F. So remember, this F is not this F net. They are different. Okay. So you have this upward force, and then you minus mg. W, this W, right, is equals to mg. So it will be 14,000 times g, which is 10 over here. So you can solve this equation, and then this will be your answer for your part C. So in this case, it seems that there is no drag force, there's no air resistance, it is just your upward force and the weight. Yeah. So as you can see, even I sometimes make mistake. I over generalize it, but I quickly make adjust, and then I got it correct. Okay.